In this video, I am going to talk about the Thevenin's experiment. Thevenin theorems, it states that any complicated circuit can be redrawn as a simpler circuit in which we have VTH in series with RTH in series with RL. Now let us discuss that how this practical can be done. First of all, let us consider this circuit diagram. Input voltage Vs set to 5 volt, R1, R2, R3. We have taken 3 resistances which are connected in this arrangement. The value will be 220 ohm. That is, we have red, and brown. Load resistance 1 kilo ohm. Brown, black and red. Now what is our task? Our task is step number 1, we have to calculate current IL flowing through load resistance RL, and this can be done with the help of this ammeter. So this is our step number 1. Calculate IL current flowing through RL. Step number 2, in Thevenin circuit, step number 2 is remove RL and calculate open circuit voltage. So we have already removed RL over here. Once we have removed RL, we are supposed to calculate open circuit voltage. Now if this is an open circuit, across this R3, there will be zero current which is going to flow because now we have an open circuit. Thus, VTH is nothing but the voltage across resistance R2. Thus, we are supposed to connect voltmeter in parallel with R2. This will give us the second value, step number 2, VTH. After which, step number 3 is the calculation of RTH, that is Thevenin's resistance. So how it will be calculated? It will be calculated manually. And for that, we have to remove Vs. So this is our Vs. We have to remove Vs and then we have to go for short circuit. Now please observe this circuit diagram. R1 and R3 both are connected in parallel with each other. Why in parallel with each other? Because you can have a look over here. Both the terminals are directly connected with each other. So if both the terminals are directly connected with each other, R1 is in parallel with R3. So you can have a look over here. After which, connected in series with R2. So that means R1 in parallel with R3. As we have same value of resistances, resultant comes out to be equal to 110 parallel connection plus 220 ohm series connection, that is R2. Thus, RTH comes out to be equal to 330 ohm. The color coding will be orange, and brown. The final circuit diagram, step number 4, which is Thevenin's equivalent circuit, in which what we are going to do, VTH connected in series with RTH, that is 330 ohm, connected in series with RL, 1 kilo ohm. Obviously, we are supposed to connect this ammeter over here in series, because ammeters are always connected in series as the current remains same in series circuit. So we will calculate IL in this circuit diagram as well. So how we will be able to prove Thevenin circuit, Thevenin theorem? IL in circuit diagram number 1, that is step number 1, will match with current flowing in step number 4. Hence, Thevenin theorem has been proved. This is regarding Thevenin theorem. For the Thevenin circuit, the first circuit diagram consists 3 220 ohm resistances and 1 kilo ohm resistance. The 220 ohm resistance consists of red, brown. So let us take first of all 3 resistances of 220 ohm resistance, that is red and brown. So first of all, this is how you're going to make the connections in a single column. Then only all these 3 terminals are going to be connected with each other. Next is load resistance. So this is your load resistance, 1 kilo ohm, brown, black, red, 1 kilo ohm. So now let us connect this 1 kilo ohm resistance with one 220 ohm resistance, and now we are supposed to connect ammeter in series. So let us take ammeter now. So first of all, the positive of ammeter will be connected with 220 ohm resistance, and the negative of ammeter will be connected with 1 kilo ohm resistance. Thus, we will be able to calculate the series current flowing through load resistance RL. Now the last, power supply. The positive of power supply is connected with the first terminal of 220 ohm resistance, whereas the negative terminal is connected with 220 ohm and 1 kilo ohm terminal. So again you can have a look. I have connected in a single column all these connections, and the input must be set to 5 volt. Right now I am using channel B, so channel B must be pressed. So let us increase the voltage to be equal to 5 volt. So input has been set to 5 volt. Now let us switch on this ammeter. So you can have a look. We have got around 1.81 milliampere as the step number 1 IL flowing through RL. Step number 2, calculation of VTH. For the calculation of VTH, remove RL and calculate open circuit voltage VTH. So now if we are supposed to calculate open circuit voltage in between these two terminals, open circuit means there will be zero current flowing through this resistance. So that means VTH is nothing but the voltage across this 220 ohm resistance. That means now we are supposed to calculate VTH across this 220 ohm resistance. So how will be the connections? Positive of voltmeter is connected with the first terminal of this 220 ohm resistance, whereas negative is connected with the other terminal. That is the parallel connection. So now you can have a look. VTH comes out to be equal to 2.5 volt. This is VTH. Step number 3 is going to be the calculation of RTH, and it will be done manually. RTH comes out to be equal to 330 ohm. So what will be the color coding for RTH? So this is your RTH, orange, orange and brown. So this is the color coding for RTH, 330 ohm. Now let us design the last circuit diagram. What is the last circuit diagram now? Let me just remove all the previous resistances. First of all, the input supply is connected in series with RTH. So this is the series connection of supply with RTH and in series with RL. So RL 1 kilo ohm, this 1 kilo ohm. But yes, we need to calculate current as well. So ammeter will also be connected in the same series connection. So let us again use this ammeter over here. So the positive will be connected with RTH, negative will be connected with RL. VTH in series with RTH, in series with RL. So this must be set at VTH. So what was VTH? 2.5 volt. So let me just decrease its value till 2.5 volt. So now you can observe it, 2.5 volt VTH, we have got approximately same value, 1.8. Hence, the current flowing through RL in step number 1 and step number 4, that is Thevenin's equivalent circuit, comes out to be equal to each other. Hence, Thevenin theorem has been proved.